planets orbiting in the habitable zone, where liquid water could exist on the surface, kissed by a star.
But this is a lie. This is Europa, a moon of Jupiter.
Its surface is a frozen wasteland, colder than our deepest Antarctic night.
But the most exciting frontier in the search for life is not on the surface. It's beneath it, because this barren ice.
And beneath that shell lies the single most promising target in our solar system.
An ocean that holds more water than all the oceans of Earth combined. This is episode 3.
How do we know it's there? This isn't just a guess. In the 1990s, the Galileo space...
What it found was astonishing. The moon had a disrupted magnetic signature, one that could only be explained if a...
Then there's the surface itself. It's not a solid, ancient block. It's cracked, shattered, and twisted into chaos terrain. Regions where the icy crust has clearly broken apart, shifted, and refrozen, as if it were floating on something vast and liquid below.
This is Enceladus, one of Saturn's moons. In 2005, the Cassini spacecraft made Cassini did something incredible. It flew right through them. And it tasted the ocean.
It found water vapor, salts, and, most importantly, complex organic molecules and tiny grains of silica sand.
That silica is the key. Those tiny sand particles can only form when hot, mineral-rich...
This was definitive proof. Miles beneath the ice of Enceladus, there is a hot, rocky seafloor. So, how could life survive in this total darkness, miles beneath an icy shell? On Earth, the sun is the base of the food chain. In a dark ocean, what would life eat?
Entire ecosystems divorced from the sun. The creatures here don't eat sunlight. They eat chemicals.
They thrive on the cocktail of chemicals gushing from the vents: methane, hydrogen sulfide.
These mats of bacteria become the grass of the deep.
Amphipod shrimp, horseshoe crabs, and tube worms feast on them.
But what provides the heat? What powers these vents?
These moons are in a constant, brutal tug of war.
This process is called tidal friction. It generates enormous heat, melting the ice to form an ocean.
And keeping the rocky core geologically active. It creates volcanoes and hydrothermal vents on the seafloor.
This means these dark oceans have all 3 ingredients necessary for life as we know it.
So, what could be living there? This is no longer wild fantasy. This is plausible science. The base of the food web would be the chemosynthetic bacteria, forming thick.
The dark oceans of our solar system are not science fiction. They are real. They are active.
Measuring the ice, and even sampling the plumes that may be erupting from its surface. We've searched for life on distant, Earth-like planets, but the first definitive discovery of extraterrestrial.
It may come from a cold, icy moon, right here in our own backyard.
Hiding a dark, warm ocean, teeming with an ecosystem we have, until now, only been able to imagine.